Hello, everyone, and here we are live on day two. So, I would love if you can just give me your names, whoever is present, and then we can begin in 2 minutes. I hope you are able to see the picture clearly. I hope you are able to hear me properly. And if everything is okay, then please say hi in the comments. Please tell me that it's okay, it's all right. Okay, so let me start putting a comment. Hemanta ji, welcome, and I also welcome you all. Great. So I hope the screen is okay and everything is fine. And so I did a big mess up. So whenever we speak about technology, this is what happens. So whenever we speak about technology, so it was just 10 minutes before 6, just 10 minutes ago, and I was all set to go live, but me and our program director Anup, we were just discussing few technical things, and by mistake I clicked go live. So it was 10 minutes before 6, and by mistake I have clicked go live, and we went live and we are still discussing something. So I realized my mistake, that I pressed a wrong button in the software. StreamYard is the software which we are using, and by mistake I realized I have pressed a wrong button, and I quickly said stop. And I quickly said stop, and the live broadcast ended. And it ended, which means YouTube declare, okay, your broadcast is finished. And the link which I have circulated to 1100 people became zero in 1 minute. So again, in last 5-7 minutes we created a new link and we posted it. Now that's a problem, because those 1100 people have received a link which is not working anymore. So I hope they will come here on YouTube and to my channel, and then they will see this live broadcast happening. But I don't know who will take that much pains to come and check for the link on the channel. If they don't, they will simply get a message. I don't know what message they will get, but I'm thankful that at least all of you are here, although the link has been disabled. So this is a new link, but of course the broadcast is the same. And whoever is present, let's begin. We don't have to worry about who is present, who is not, what can I do. So at least they will get the replay after the broadcast has finished, and probably they will be able to enjoy the replay. Our aim is to share the knowledge. It is great if there are so many people online. Like for yesterday, the total online count was 153. So it is okay, and today I see the count is more than 300. So around 150 people have seen the replay, which is okay. But if they are live and if they are participating in the comments, then it gives me additional energy. So all of you who are saying hi to me, I say welcome to you all. And let's go to our slide presentation. And so this is a wonderful software uh, which is called StreamYard, and which I have put in on my PC here. Also, Anup has done it on his PC. So he stays in Pune, I stay in Nashik, and we have installed this software. So because of this, Anup and me, we both can control this live broadcast with you. We can add slides, we can add videos, we can put comments. So without me going on YouTube, just by using this software, and we are using a free version of the software, we are still not paying. So there are two administrations possible, Anup and me. But if I want a third person, one more tip member, then it becomes a paid plan. So wonderful free software which can be used. And when I do interview of Professor Shetty on coming Wednesday, we will be using the same software. So Professor Shetty will be there sitting in Mangalore, I will be here, and you will be able to see two people speaking. So I'm taking his interview, and that's how we will do it. So the technology has tremendously changed, and COVID has given a lot of push to this change in technology. My question to you all is, how you are going to use the technology. Are you only going to watch the videos, the Facebook posts done by others, or are you going to participate in the content creation? Whatever civil engineering knowledge that you have, that's the question. But let's go ahead. So today we are here on day 2, and today what we will see, uh, as I mentioned to you yesterday, we all know only about the compressive strength. So we start with concrete mix design, we check the slump, we check the flow of the concrete, and then we check, once the concrete is set in place, we take the cubes, we check the compressive strength 3 days, 7 days, 28 days. Few people take it for 56 days or 90 days also, if it is allowed, which I was mentioning yesterday. This MSRTC project, PQC concrete, it was allowed to check 56-day result. Although we tried hard for 90 days, but at least we got successful 56 days. So probably first concrete in India, a government concrete, where the client allowed to check 56-day result, and if we are not meeting the criteria on 28 days, we were allowed to check it on 56 days. So that allowed us to use 35% fly ash in concrete. Great boon, isn't it? So cost saving as well, because as we all know, fly ash cost is less than half cost of OPC, and you are allowed to fully utilize that fly ash by waiting up to 56 days. Okay, so that's what we spoke yesterday. Up to compressive strength we all check, maybe 56 days, maybe 90 days. But what are the other properties which we are going to see today beyond compressive strength? So that is the first part of our presentation today. And in the second part, we discussed yesterday that we are going to discuss two methods how you can build your knowledge over next remaining career of your life. How you can build. So one is the scaffolding way, and the second is problem solution way. So these are the two things we will see today. And learnings from day one, very quickly I will go through them again. uh, I'm always looking at the clock, to see that I don't spend too much time on something, so that we will have little time left in our 90-minute span for other things. Okay, so yesterday we discussed that the future belongs to the expert. So somebody had asked a very nice question, and I didn't answer it yesterday. How many civil engineers are there in India today? So Indian construction industry is going to be the largest employment giver in our country as a industry. That means by year 2022, 75 million people would be employed by this industry, out of which around 50 lakhs are civil engineers. What happens to other civil engineers? So many join the profession. Every year we have seen 4 5 lakh people are added. So we are talking only about last 10 years. If we calculate like that, 50 lakh civil engineers working. These are all estimates. I got this figure from a study done by Economic Times, and it is available on Google. You can check it. But there is no pakka foolproof answer to the question. But the answer is about 50 lakh, 5 million. So my hunch's answer is probably more than that, more than 50 lakh civil engineers working as civil engineers today in India. Not I'm talking about passed out, they have passed out and probably doing something else, but people who are in construction industry working as civil engineers. So the future belongs to, out of this 50 lakh, top 3%. How much that would be? You calculate it. It should be somewhere around 1.5 lakh. So 1.5 lakh is the cream of this 50 lakh. My question to you is, yesterday I had given you 3 questions and you were supposed to answer them. So my question to you is, out of this 1.5 lakhs, can you become one of them? And that is the thing which we saw, that the future belongs to the expert. The second is, we saw how to become an expert. So we saw the formula: why success, your success, why success is equal to demonstrate consistently your talent. How we do that, we will quickly see today. How you can actually do that, okay? And then, of course, we had seen about four brothers. You remember them? Should I ask them? No, I'll ask you a different question to type. Let me give answer to this. So tricalcium silicate, dicalcium silicate, calcium silica, calcium silica. One has three molecules, one has two molecules. Always remember this rest of your life. Four brothers staying in the house called cement. You will remember it, okay? Promise me, right? Four brothers. You are promising me? Yes? Good. Four brothers staying in the house called cement. Tricalcium silicate, dicalcium silicate, two calcium silicates. Tricalcium aluminate. So tricalcium silicate, tricalcium aluminate, same. C3S, C3A. C3A, the third brother, we didn't speak much about him yesterday. He's the angry young man. So in IS code, you will find that although tricalcium silicate, dicalcium silicate, no specification, no restriction on the composition. But this angry young man, the third brother, who has got aluminate in him, C3A, there is a restriction. You cannot have more than 8% C3A, because too much and you'll have problems with your initial setting time. The cement will settle very quickly. It will become hardened very fast. And sometimes, one in million, we find that some batch of cement, there was some problem of setting. Normally, the problem is not the cement is not setting. In some cases, there is flash setting happening, immediate setting, which is the culprit is the third brother. C3A. C3A is helpful in our concrete when it comes to attacking the chloride ions, but that's a completely different subject, and probably we can speak only on cement chemistry someday. So that is the third brother. The fourth brother we saw, tetracalcium aluminoferrite. Very long name, but don't worry about him. He just holds the other three compounds together and also works as a catalyst whenever the hydration of cement taking place. So although he doesn't directly participate, but very important pillar in our cement, and these four brothers form our cement. Then I came to the hydration of cement yesterday, and C3S and C2S reacting with water. You remember that mixer, that equation, and we get CSH gel, which gives us early strength, delayed strength, and then there was the hero of our presentation. So type in your comments, who was the hero of our presentation? What is the chemical name for him? So I called him Arjuna, just to fix the things in your head. But what is the chemical name of the hero of our presentation yesterday? Type it. This hero, I said, is a confused person, right? But then over the period of time, if you can give him a dose of silica, if you can give him the dose of alumina, then this hero, his confusion is removed, and then he participates in hydration. So what is his name, the hero of our presentation yesterday? I hope my question is clear. Thank you, Sanjay, so much. Sanjay Karne, our star as usual, the first one to give answer. Calcium hydroxide. Thanks a lot, Sanjay. So that was the hero of our presentation. And whatever taught to you yesterday, what you are going to do with it? भूल जाएंगे? चलो, सेशन खत्म हो गया. आधा पौना घंटा, एक घंटा कुछ नॉलेज मिला, और फिर नेक्स्ट डे हम आ गए अपने रूटीन काम में. सो वी आर फॉरगेटिंग अबाउट इट, बट दैट विल नॉट हेल्प. Yes, yeah, Oish, thank you so much, Mr. Mohammed. Thanks a lot for your answer. Okay, so what to do with the knowledge that we are gaining every day? If you go on YouTube, so many wonderful videos on civil engineering, on concrete. Every day, some webinar is happening somewhere. Various cement companies, Ambuja, Ultratech, they are holding it. So much knowledge is there free of cost. What are you going to do about it? We'll discuss about it. So I have promised you that I will tell you a story today as I begin, because I came to fly ash and somebody asked me a beautiful question. What about this crushed sand and the pumping problems that you are getting? And then I said the solution to that we will discuss tomorrow. Today, all our quality control engineers, civil engineers who are working in the concrete field and who are there with us today, all of you, you know one thing. This sentence. What is this sentence saying? High strength you achieve through your mixed design. So you do your mixed design in your laboratory. But this does not mean pumpable concrete. So let me take you back uh, around 20 years or slightly more than that, 23 years. Year was 1999, and I remember that Monday. I will never forget that Monday afternoon. I am standing on the site. We have designed our mix M45 grade concrete. Demonstrated strength was 16 Newton per mm square. The project was Marine Outfalls, one of the most prestigious projects ever done in India. And I am the poor guy, just few years of experience working as the concrete designer. And we designed M45 70% GGBS के साथ 60 MPa strength. Those were the days where PC plasticizer was not heard of in India at all. Okay, and 70% GGBFS, 30% OPC. Target strength is M60. Characteristic strength was M45. Why 15 MPa? Because British standard was there for that project. All the consultants were foreigners, Binion partners, all British guys working on the project, sitting on our head all the time, and they wanted to see that 60 MPa strength. Somehow I managed to do that. That's a different story how it was done. Someday we will share that story. But here I am there on site now. Concrete mix design is approved, but the concrete has to be pumped 200 feet below the sea level, 4 kilometers inside from the shore. So very challenging job. The concrete was produced, it was in Mumbai, the project was in Mumbai. The concrete was produced in BKC. ACC was the concrete supplier. They had been nominated to supply. And the concreting was to be done at Worli. So take the concrete from Bandra, take it to Worli, drop it down into the shaft, 200 feet, put it in a Mulehäuser. Mulehäuser is a German term for a ready-mix vehicle. But this Mulehäuser, it doesn't rotate when it is transferring. Why? Because inside the tunnel, it cannot consume fuel for that. So put it into Mulehäuser, take it 4 kilometers inside, then you begin rotating the drum, then remix the concrete and pump it. 70% GGBFS. My God. So there was a first concrete trial. Everybody was there. My bosses, they were Germans. The company was divided. The consultants were British, and I'm there showing them the pumping trial. And we began pumping the concrete. And in the very second or third stroke of the pump, that is the sound we should get. But we are getting that's kind of the sound we are getting. So then I learned how from the sound you find out whether the concrete mix is good or not, just by the sound of the pipeline. But anyway, that was later. So on that day, on the third stroke, the pipeline choked. The concrete refused to move. Okay, so the concrete was giving me the strength, high strength which was required, but it doesn't mean that it is pumpable concrete. Everybody was looking at me. What is happening? We are opening the pipeline, doing this, doing that. 3 hours we spent. We threw away a lot of concrete. Again, ordered the fresh concrete to come. One more transit mixer. Let's try this. Every transit mixer that came, all the pumping trial failed. Believe me, this is only on the surface. We have not yet gone in the tunnel, and everybody is asking me, surface ke upar you are not able to show how this concrete will pump inside the tunnel. And I remember it was the Mumbai heat, and I was perspiring fully, part of it because of the heat and part of it because of the shame, because it was a flop show. In front of, at least there were 50 engineers, my colleagues working in the company, my bosses, the German bosses, and then the Binion partner engineers who were there, they were British. So, and then it was Mumbai Municipal Corporation job, so corporation engineers as well, and it was a big flop show. Probably we all get these kind of problems in our career. Sometimes you all must have also witnessed such a horrible failure as a professional engineer. And I will never forget that day. I was perspiring and it was a big flop show, and my boss started shouting at me, what you have done, you can't design a basic concrete. But none of us were aware that the problem is because of GGBFS, 70% GGBFS. Normally pumping of concrete should have been easy, but that was the first project in India where a 70% GGBFS concrete was supposed to be pumped. So if you go under a microscope, take a grain of GGBFS and look at it, you will find it is flaky in shape, right? And if you take 1 grain of fly ash, so this is a slide. If you take 1 grain of fly ash and look it under microscope, you will find it is perfectly spherical in shape, like a ball bearing. And okay, my boss was very angry on me on that particular day. But next day, he called me in his cabin, Mr. Klaus Munz, and he said, Mr. Joshi, do you know that in Europe, we use fly ash in concrete, which helps us pumping. It was year 1999. Even for Europeans, it was a new concept. But thank God my boss had heard about it. Or maybe he called someone, I don't know, in the previous night, how to make the concrete pumpable. I said, sir, ash. He said, yeah, from the coal. I said, sir, ash from the coal you want to use in concrete? I thought my boss has gone mad. Who will use ash from the coal in concrete? It will spoil the concrete. He said, no, Baba, go and check first. It is a good thing which is used in many prestigious structures in Europe now. And it also helps pumping. So then I started finding out, and then I came to know there is some company just coming up end of 99 year 2000 in Nashik, who will be processing fly ash and selling it to concrete. Oh my God, I thought my luck, is favoring me finally. So I started doing lot of study of this material called fly ash. Then we discovered that if you use certain amount of fly ash, 20 to 30%, it will take away the GGBFS problems. And that's how we came to the ball bearing effect. Friends, this word BBC, ball bearing concrete, I have coined this phrase. I don't know if anyone else has done in the world before me, but I think not. And sometimes I think that I should get a trademark for it, BBC, ball bearing concrete. So any concrete which has got fly ash content, uh, to compensate not only GGBFS, but in today's world, also your crushed sand. Over last 10 years we have seen that river sand is completely out from the market. It is banned and we are forced to use crushed sand. 150 micron passing of crushed sand, we all know, it should be less than 10%, but unfortunately IS code says 20%. 150 micron passing, in my opinion, if you can have, if you can reduce that dust, it would be a great help, but it is not possible. And we have to use crushed sand which is approved by, is allowed by IS code. So we found some curves, we designed some curves, some graphs which show you as the 150 micron passing is increasing, what should be the content of your fly ash. So those are called BBC curves, addition curves, subtraction curves. And in some separate program we can only discuss about the BBC concrete, how we can do. But that was the story I wanted to tell you yesterday. That is not our topic today, and already consumed 22 minutes discussing this. So this is our today's topic, this cyclone. Can you see the trees of this cyclone and how they are bent like that? So I had a mentor during my very early years, 91, 92, Mr. T.T. Fatehi, great civil engineer and also a structural designer. And he told me once, Mr. Joshi, do you know why we have these columns thick and why the coconut trees are so thin? Coconut tree is a horrible cantilever structure, isn't it? You see, so much load is there on top of that tree, and then the wind blows, but the coconut tree doesn't fall. So, what is civil engineering behind this? And why, for our building, we need such heavy columns? Not one, this is a single column structure, a coconut tree, but we need 4, 6, 8, 16 columns. We need a core wall whenever we are building a skyscraper. So why is it, he asked me, that we engineers cannot design a structure like a coconut tree? So I said, sir, maybe our technology is not so much. Maybe we don't understand the materials the way the nature understands how to design the materials, like that trunk of the coconut tree, how elastic it is. So he said, yes, that's the right answer, the modulus of elasticity. So a coconut tree has a certain modulus of elasticity. It is so elastic that that elasticity takes much of the load. But he said, if I design my building like that, will you stay in the topmost floor? If there is so much deflection, we will not stay, we will run down. So that's the problem. That's why, although the concrete is allowed to deflect in a certain way within the safe zones, but we cannot design it that way. Otherwise, nobody will stay in that 17th story. So there is a certain displacement given in the codes, allowable displacement. More than that, you cannot allow your building to deflect. You cannot allow the top point to displace by more than that. So this point gave lot of thinking points to me at that time. Particularly this term modulus of elasticity. In all our college days, we have used the value of E, the modulus of elasticity, in solving all the problems. But I never really understood this term, modulus of elasticity. So today we will see a few of these terms, as I said, from the Bible of our civil engineers, IS 456. So all these terms are defined, are given in our IS code, and we should look at them and understand them, because that is where the real durability of our concrete comes from. So compressive strength we all know, right? Compressive strength we all know. But the question is, do you understand strain? Everybody, 100%. What is strain? What is strain in concrete? So you take a certain object and you apply pressure on this object. Okay. So this is just a bottle and I am applying pressure on it. So when I apply pressure, I am generating stress. When I apply pressure, I am generating stress on it. So whenever there is stress on an object, there is change in the length. So assume that this bottle is 1 meter long and I am pressing it, I am applying some stress. In civil engineering, let's turn it around. Let's say this is our cube and I am applying stress on it. Okay. Yes. So here it is, our cube, and you are applying stress on this cube. So the moment I apply stress, the height of the cube, which is 150 mm, is going to change. The height is going to reduce, and that is what strain. So strain is dl by l. Mr. Patil, thank you very much for your answer. Change in length upon original length. Very simple concept, right? But the problem is the modulus of elasticity, we define it as stress divided by strain. So let me say, on this cube, I have applied lot of stress, and let's say this stress is M20 grade concrete. Okay, so 20 Newton per mm square. So stress is nothing but the strength of your concrete. Okay, so whenever we get confused, are what is stress? Don't take stress because of that. So stress is our strength of the concrete. So M20 है concrete आपका 20 Newton per mm square. Okay, so now I am pressing it, and after pressing it, a 1 meter beam or 1 meter column of concrete, it deflects by 1 millimeter, only 1 mm. The length is reduced by 1 mm. So stress 20 Newton per mm square divided by 1000, because 1000 is the original length and 1 mm is the change in length. What that creates is that ratio gives you modulus of elasticity. Now the problem is, this is a wrong word, modulus of elasticity, because the stiffer is a substance. Please take this one point from this presentation. आप बाकी सारा भूल जाएंगे आज तो भी चलेगा, but this one point you will not forget. Okay, promise me, right? So what I am saying is, modulus of elasticity is a wrong word. Why I am saying? Because higher is the modulus of elasticity, lower is the elasticity of the material. Higher is the modulus of elasticity, lower is the elasticity of the material. Because the more force you need to create a small change in length, the material is more rigid. So the right word should be what? Modulus of rigidity. So if I compare concrete with a rubber band, Somebody will answer the question, please. Listen it carefully and answer it. So there is rubber band and there is concrete. Who will have high modulus of elasticity? So you have to answer this question. Concrete compared with rubber band. And who will have higher modulus of elasticity? If you have understood whatever I have told you just now, you'll be able to quickly answer. Is it the concrete which has higher modulus of elasticity, or is it the rubber band which has higher modulus of elasticity? So tell me quickly. Concrete is Krishna. Mr. Krishna is saying concrete. Thank you. Who else? Concrete will have higher modulus of elasticity. Is this the right answer? I don't know. Concrete will have higher modulus of elasticity compared to rubber. What will have higher modulus? Everybody is saying concrete. Yeah, again concrete. Krishna is saying again concrete. Concrete will have higher modulus of elasticity, or rubber will have. All of you are sleeping. So many people are there online. All of you are sleeping now, or what? I want answer now. Otherwise, how I can proceed? Rubber. Okay. Apurva is saying rubber will have higher modulus of elasticity. Great. Who else thinks? Give wrong answer, but please participate. एटलीस्ट आपका नींद तो चला जाएगा, उसकी वजह से आप पार्टिसिपेट करेंगे तो, राइट? नहीं तो आप सिर्फ सुनते रहेंगे मेरी बड़ तो आपको नींद आ जाएगी, राइट? सो आई ट्राई माय बेस्ट. हेमंत is saying concrete and Apurva is saying rubber, Krishna is saying concrete, Mr. Mohammed is saying rubber. मेरा सिंपल क्वेश्चन है, कंक्रीट का मॉडुलस ऑफ इलास्टिसिटी ज्यादा है या रबर का मॉडुलस ऑफ इलास्टिसिटी ज्यादा है? इतना मेरा बेसिक क्वेश्चन है, और अब मैं जवाब दे देता हूं. मॉडुलस ऑफ इलास्टिसिटी कंक्रीट का ज्यादा है. ओके, सो इसके लिए रीजन क्या है? जैसे मैंने कहा, ये गलत वर्ड है मॉडुलस ऑफ इलास्टिसिटी. सही वर्ड क्या होना चाहिए था? द राइट वर्ड शुड हैव बीन मॉडुलस ऑफ रिजिडिटी, बिकॉज हायर द मॉडुलस ऑफ इलास्टिसिटी, हायर इज द रिजिडिटी, लोअर इज द मॉडुलस ऑफ इलास्टिसिटी. जितना मॉडुलस ऑफ इलास्टिसिटी कम, जितना मॉडुलस ऑफ इलास्टिसिटी कम, उतनी उसकी इलास्टिसिटी ज्यादा है ना. अजीब कंसेप्ट है. So whoever has coined it is a wrong word, is a wrong phrase, and this one point you don't forget in your life, right? And after this presentation, think about it. Stress divided by strain, right? Stress divided by strain. The more stress you need, the more pressure you want to give, the more rigid the object is to create a small change. Chalo, enough on this. So there is a formula I have given. If you know the compressive strength of your concrete, let's say the compressive strength is 30 Newton per mm square, 30 MPa. Okay, take a square root of 30. क्या रहेगा square root of 30? 5 point something, right? I have written there 5.4 multiplied by 5000, and that is, Krishna is saying something in shear stress strain. Please clear. I am not able to clear this point now because I will have to give you complete picture. So Krishna, maybe please allow me if I can type a long message about it later on. And it's just still the first slide and we are already at 6:30. So Mr. Krishna is asking that modulus of rigidity term is used in shear stress strain. Please clear. Whether you call it modulus of elasticity or modulus of rigidity, it's just different way of saying it. So modulus of elasticity is not 1 divided by E. It is still E. So, but somebody decided, let's start using the right phrase and call it modulus of rigidity. It is modulus of rigidity. It is modulus of rigidity. But since a long time, the term started being used was modulus of elasticity. Okay, my friend Ajay is also there. Thanks Ajay for joining us today, and let's go to the next slide. Can you see this curve? Because as I'm sharing it, I'm not able to see it. So somebody please Mr. Hemanta, can you see the curves on the screen? Please just let me know if you are able to see the curves on the screen properly, because I'm not able to see the lines. No, it's too bright or something, some issue with my screen. So either Anup or Mr. Hemant or anyone, please clarify that I am showing you some a graph here, and no, you can't see that, na? So I don't know. Probably this is a issue with the software that I'm using. So that's a problem. You do something in PowerPoint, and when you are presenting it, it's not there. No problem. We will explain it very quickly. So this is a curve which shows that the modulus of elasticity of aggregates, of cement paste, and your concrete. So the problem is, it's okay, no problem. You are not able to see it, fine, no problem. If I go ahead, these curves are much visible. Okay, fantastic. So let me go to the next slide, and there are some curves here and they are visible now. So uh, it is the same graph. It is the same graph, but that graph was showing. Let me take you back. That graph was showing the strength, the stress on y-axis, and the strain on x-axis. Okay, so stress on y-axis and strain on x-axis. So you can see that the modulus of elasticity of aggregates is very low. So please, I'm just giving you these fun examples, but don't take them in some other way. So I'm just trying to give some fun examples to make the point clear. So there are these three guys, okay, three friends. One is aggregate, one is concrete, and one is our cement paste, which is in our concrete, right? और ये तीनों की wives है, all of them have a wife, okay? So the wife of aggregate is a very strong person. Uh-huh. Oh my god, now you can see it, isn't it? I don't know what has happened, but suddenly I can see the lines. Wonderful, 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 wonderful. Something happened, chamatkar. So the wife of aggregate is a very strong woman. Even if the aggregate puts lot of stress, बहुत झगड़ा करता है wife के साथ, okay, he fights with his wife a lot, but she doesn't go too far away from him. So strain is what? Change in length. She doesn't go away from him. So aggregate is a very stable marriage. So whenever you use aggregates in your concrete, it gives you a lot of stability. Remember this point. You might be thinking what all this theory has to do with durability of concrete. We are coming to that. So aggregate, his wife doesn't leave him. Very stable marriage. Even if there is lot of stress, there is no strain. The distance doesn't increase. Your beam will not deflect too much. It will not form micro cracks. That is the property of aggregates. Now we come to the cement paste. Now we come to the cement paste wife. You know what to tell you. थोड़ा भी झगड़ा हो गया, she will go to her मायके. Okay, she will go to her mother's place. So that's the problem with our cement paste, because there is so much strain. You can see that for the same stress, just check between aggregate and cement paste. So there is a horizontal line drawn. For the same stress, for the same load coming, the aggregate will not move, no change in length. But the cement paste, there is rapid change in length. There is rapid change in length. Therefore, IS 456 has given you now maximum cement content. Don't use cement more than 450. Why? The more cement you use, there is going to be more strain. There is going to be more micro cracks. All other issues are also there with higher amount of cement. Few years ago, it was considered good. Dalo cement jitna dalna hai concrete mein. Now the concept is reversed. Use as less cement as possible without sacrificing the strength of concrete. Use as less cement as possible without sacrificing the strength of concrete. Golden letters this sentence should be written. And IS code realized it after concrete technologies fought with Bureau of Indian Standards for many years. Put this clause of maximum cement content, more than this not allowed, and finally it was incorporated. But anyway, that's a different story. So we're talking about cement paste. Little stress and the wife runs away. The strain increases. Okay. Now the concrete is made up of aggregates and cement paste, right? The concrete is made up of these two, aggregates and cement paste. So you will expect that concrete ka modulus of elasticity would be somewhere in center, which you can see. Concrete is in the center, right? The modulus of elasticity is somewhere in the center. But the problem is with concrete, the modulus of elasticity is a curved line. Can you see it? So this is a curved line, when actually cement paste and aggregates more or less there are straight lines. So increase in stress, increase in length. Okay, aggregate not so much, cement paste too much, but straight line relationship. But concrete doesn't have straight line relationship. So because it is made of these two different phases, aggregate phase and cement phase, PHASE, two different phases. And when these two phases combine, on the intersection of these two phases, on the boundary of these two phases, on the surface of your aggregates, the weak zone starts forming. And this weak zone, no prediction how it will behave. So it starts behaving, जैसे प्रेशर बढ़ जाता है, जैसे स्ट्रेस बढ़ जाता है, as the loading increases, this transition zone, what we call, between aggregate and cement paste, starts behaving in a funny way, which makes this relationship a curved relationship. So all these points are important if you want to design a stable concrete. So as I mentioned yesterday, for a normal building, nobody will think about this. But when you are designing a structure for 120 years, or as I saw yesterday, for 500 years, one of the LinkedIn articles, I will try to circulate it to you, the link. They are trying to design the structure for 500 years. So you need to take care of all these issues, right? So you saw about all this, about aggregate and cement paste, about their wives. So one wife is strong, one wife is, even on small pressure she will go to maike. And about the cement paste, about the concrete, the relationship is completely different, unpredictable slightly. So the curve shape says that initially the concrete is able to take the pressure. That is what the curve shape is telling you. Concrete is able to take the stress initially, but as the stress increases, the strain starts running quickly. So at a higher pressure, at the higher stress, at the higher loading, the deflection is too much. So therefore you have to design your concrete also properly, particularly long spans where deflection could be an issue, particularly for your bridges where the load is heavy. And we will see in the next few slides about the creep. The problem starts from modulus of elasticity and it ends in creep. Okay, let's go ahead. So friends, this is also a slide that we covered. I already spoken about this. Higher the strength of concrete, higher is the modulus of elasticity. So that helps. We don't want to have concrete with low modulus of elasticity. We don't want that. Rubber band जैसे घर में हम रह पाएंगे. If there is so much deflection every time, if there is so much change in length every time, we will not be able to stay in such a house. So higher the strength of concrete, higher is the modulus of elasticity. And sometimes designers take help of this particular property of concrete. So your compressive strength requirement is only, let's say, 40 Newton per mm square, but they will design it for 60 so that they can control the strain in concrete. You want to control the strain, the deflection. In certain unique cases, this can be the case. So once we understand modulus of elasticity, then we can speak about shrinkage and creep. Let's go to the next slide. So we all always hear about this word shrinkage, which are two types of shrinkages. Can Anyway, first answer I have already given in the second point, plastic shrinkage. So plastic shrinkage and drying shrinkage. And these are two enemies of all our civil engineers. If you are working for a RMC company, you will know, or you are the concrete supplier, or you are the contractor, then you will know client will come and blame you next day once you have done a nice slab. So you are doing the concreting, let's say it is 20th story concrete, okay, and you are doing the concrete, and next day you come and you find big cracks on your slab. It has happened with you? Yes. If it has happened with you, just type yes. If you have seen cracking on the slab on the next day, just type yes in the comment, so that I will also know that you are still not asleep. Okay. And just type the answer quickly. Let me see who all types. I want to check that. So all of you have faced. Sorry, my mic was muted, and I just realized it that my mic is mute. But now I hope you are able to hear me. Okay. So we have seen that all of us have faced this problem in our life, and what is the solution? So the problem, from where it is coming, it is coming from plastic shrinkage. So the concrete can have plastic shrinkage, it can have drying shrinkage, two types of shrinkages. And we will see that. So there are three blanks I have left. I'm sorry, but slightly thoda fast le lete hain session ko, because it's already 6:50. And let's see how we go ahead. So there are three issues. I think this one point I should make clear before I go to our next point. Plastic shrinkage, because you can use this point straight away from tomorrow. You go back to work and you can use this point. Cracking of concrete comes from three problems. One is high temperature. Chalo, now the season is good, cold climate, not so much problem. But the moment you start, the March starts approaching. March, April, May, the moment these 3 months start approaching, you will have heat in the atmosphere, the water evaporation will start, and which will give you plastic shrinkage. Plastic shrinkage means when the concrete is in semi liquid stage, it is still not hard. So which means first 24 to 48 hours of our concrete, whatever shrinkage will happen is plastic shrinkage. After 24 to 48 hours, the drying shrinkage begins. But now we will not cover the drying shrinkage, we will keep it for tomorrow. Okay, and today we will just speak about plastic shrinkage, because another important topic I want to take with you today. So I don't want that we run out of time. So first is temperature control. Your temperature, you can't control the climate, so you should be aware, okay, the climate temperature is high. Second is the height of the building. You are doing the slab on 10th story, you are going to get plastic shrinkage. If you do it on the first floor slab, less chances of getting. Why? The velocity of the wind. So the wind takes the water with it as it is blowing, and it leaves the top concrete surface dry, which results into plastic shrinkage. Okay, so two outside agencies, temperature and wind, not in our control, but what is in your control? Covering the concrete. So as soon as you lay your concrete, within 60 minutes, so the concrete you have laid, 60 minutes have gone, sprinkle some water. 60 minutes, sprinkle some water. And after 30 minutes of sprinkling the water, after 90 minutes or around that time, you cover the concrete with a plastic sheet. So once you cover the concrete, you are stopping the evaporation loss because of the heat, and you are stopping the wind from taking the water away. So these are the two outside things which you are controlling by putting a plastic sheet, by starting the sprinkling of water on the concrete after 60 minutes of final vibration is done. After that, okay. And the third point is the water to cement ratio in your concrete. Keep it as low as possible. Keep the free water content as less as possible. It is again connected to that point of modulus of elasticity, which we saw. What we saw, use less cement. So if you use less cement, there will be less water available. You will be forced to use a lower water to cement ratio when the aggregate content is high and the cement content is low. So that is another point which we were going to discuss, but let's cover it tomorrow. Aggregate to cement ratio. Concept is less cement, less water to cement ratio, high aggregates, and no creep in your concrete, less strain in your concrete, and at the same time, low plastic shrinkage. All these things, they come together fortunately to help us create a great concrete. So now, friends, I go ahead and let's try to cover some important things. How to design a great plaster, even we are going to discuss that, but I will use these slides tomorrow. And now I quickly come to our most important part 2. I want to cover it in next 15-20 minutes and leave some time for questions. Audio is not proper. Uh-huh. Is the audio okay now? Can you hear me? Please confirm yes or no, because you all are saying that audio not okay. But I think these are old comments. When I had done it, kept it on mute by mistake. Probably you can hear me now. If yes, just say yes, that's all. If you are able to hear me now properly. So we discussed these two ways of the future belongs to the expert. We discussed these two things, these two methods, and thank God. Thank you, Pankaj, for confirming. Uh, this Google has 10-second delay. So what I ask you, it reaches you after 10 seconds. And your comments, they reach me after 10 seconds. So as I said, this 10-second delay, it helps the users to have a very nice streaming experience, but it becomes difficult for communication, direct communication one-to-one. Anyway, thanks. Thanks, the audio is there. I had kept it on mute by mistake when I was changing the settings. So the first one is scaffolding, which we discussed, and the second one was we discussed about the solution problem method. So how you are going to go ahead in your life using the scaffolding method. So scaffolding method is, now today you know about मॉडुलस ऑफ इलास्टिसिटी. ओके, थोड़ा बहुत तो समझ में आया. Maybe you will think about it, you will go and read about it, and you will build on this concept tomorrow. Whenever you will see some article on modulus of elasticity, you will have some interest, or you will open the book of Professor M.S. Shetty and you will go to that chapter and read about modulus of elasticity. There is another fantastic book, Structures or Why Things Don't Fall. It is available on Amazon India. Please order that book and read it. It is a general information about structures written 50 years ago. It's not about concrete, it's more about structural analysis. but in such a fun way that man has written the book. Again, it was recommended to me by T.T. Fatehi in the year 1992, and I'm grateful to him. We, those days, no Google, no Amazon. Somebody got a copy of that book, so we all took Xeroxes. I still preserve that Xerox, although I have that book in Kindle format on my mobile, but I still preserve it, that original copy. Please buy that book from Amazon India, Structures or Why Things Don't Fall, by Mr. Gordon. And this book tells all these concepts like modulus of elasticity, stress, strain, welding, why welding is harmful to the building, so many things. It's a very massive volume, and I am impressed by the way Professor Gordon explains the things. And I try to copy him, his style, about making the things so simple and in so stupid way, that even a third grader would understand. I'm not saying that you are all third graders, but whenever we are attending online session, it is difficult. Reading a book, you can read complicated stuff, but listening to somebody can be boring. And that's what I learned from Professor Gordon, to make things so simple. In the year 2001, I had written an article for ICJ, Indian Concrete Journal, one of the most prestigious magazines on concrete in India. And I described all these fun ways about calcium hydroxide, about Arjuna. In the year, I'm talking 2002, and they rejected the article. They said, such simple language is not allowed. They used a different word. I still remember when they sent it back, my article, and said, this is too far fetched what you are saying. You can't compare a stress strain with wife of somebody. This is too far-fetched. But they miss the idea that that's the way humans learn. We all learn through stories. Since last 10,000 years, all the knowledge was passed through stories, right? And story is the best way human mind learns quickly. But anyway, that's not the topic. So this scaffolding method, how you will use, so you will go and build the knowledge on that, okay, so that you go deeper and deeper into the subject. My agenda is what? To give you that seed, small seed, to plant it in your mind, and you can grow a tree out of it. That is your job. That is the scaffolding method. Start with a small concept and go on building on it on top. The second is solution problem method. So what is a solution problem method? In every solution there is a problem. So you pose a question, this, but okay, but what from that? So as I mentioned, wanted to design M45 grade concrete. It should be durable. So we use GGBS. But that led to a problem of pumping, which I was not aware. Pumping problem. How to solve it? Okay, we found out fly ash. Fly ash is useful. But from where we will get fly ash? Okay, there is this company who will supply quality assured fly ash. Okay, that fly ash will come, but then the strength got affected. How do we solve that problem? 70% GGBFS, a dose of fly ash 15 to 20%. The final OPC left was just 10% in the concrete. How you will get the strength, the initial strength that is required for decentering inside the tunnel? Okay, so we found out PC. So that is the another way, solution problem, and the way you use it, all this knowledge, if you want to carry it with you. So I expect all of you now to give me your questions, so that in 15-20 minutes I will be able to answer your questions, right? So otherwise what happens, the time goes away and the questions remain unanswered. So what you should do now is, you should try to find a small group, probably in your company, probably your friend circle, probably when you are sitting for lunch together, and at least you will begin discussing on this one concept. So discussing small group during your lunch time, to discussing to an audience online in a webinar. So that is the journey I want you to take over next 5 years in your life. And I always thought that if I can work with a close group of 20 good participants, then I would like to work with you all over 5 weeks. And we can do it in a very fun way. And that's what I've been thinking, that I can start a small group, and if you are interested, we can discuss about it tomorrow. Fees and everything is immaterial, that's not the matter. But if you want to grow yourself, so every week, every Saturday, we will learn about concrete, and I will give you some assignments by which you'll be able to demonstrate it to the outside world. So like we said, demonstrate consistently your talent. So you acquire talent, you practice it, you use that knowledge by sharing it with your friends, and then go out and demonstrate it to the public in the outside world. And how to do it? How to do it through LinkedIn, how to do it through Facebook, how to do a live telecast like this, YouTube live or Facebook live, how to write blogs, how to write small articles on concrete, whatever knowledge you have. The problem is everybody thinks I am not an expert. But if you want to grow your brand name, if you want to grow your business, if you are a senior manager, you want to become a CEO, or if you are a junior engineer and you want to become a senior manager, so any kind of transaction that you want to do in your life, any kind of growth you want to do, it has to come through transformation. And this transformation can only be created if you are able to demonstrate your knowledge. So if you are interested, you can let me know tomorrow, and we can see how we can do the month of January 5 weeks. So every Saturday we can meet, but let's discuss about it tomorrow. Now I'll tell you one story. So I have a brother, and you can see the power of a civil engineer, where a civil engineer can go. So in the end, I'm going to tell you this story and then continue my presentation tomorrow where I have stopped. So after this story, if there are any questions, we will take them. Otherwise, we will close for today. So this is a story of my cousin, and his name is Shriram, and he's a civil engineer. And one day he got some job, some site in Delhi. Now he has to travel from Mumbai to Delhi, and he's trying to find tickets. Flight was out of question, because he can't spend that kind of money, so he had to go by train. And Tatkal reservation, no train was available. The only train that he got was Firozpur Janta Express. If you know about that train, it's a very slow train. It stops at every smallest station, and traveling like that from Mumbai to Delhi is a massive task. Anyway, no choice, Delhi to पहुंचना है, ticket तो मिला है, so he sat in the train. And that train left Borivali from Mumbai, and it is stopping at every small station for 2 hours. And on the third day morning, so 2 nights he has already spent in the train. He's supposed to be in Delhi, but he has just reached halfway. He's just at Baroda station, and he's bored like death. When I will reach Delhi in a train, a local Janta train. And then he sees from other side one more train is coming, and he looked at the board, which is this train also stopping at Baroda station, and he was surprised and shocked and amazed. It was a Firozpur Janta train coming from Delhi to Mumbai. So he said, oh my god, this people in this train must be also bored to death. Halfway point, 2 days I have taken, I don't know how many days these guys have taken to reach here. So there was a person sitting in the window right opposite him in that Firozpur Janta. So he asked him, कब निकले आप? तो बोला, अरे यार, since 2 days I have sat in this train and now I reached Baroda. And he said, आप कब बैठे ट्रेन में? He is asking my brother now. Since when you are sitting? So my brother, civil engineer and a very funny person, not a very unique combination, right? But he has great sense of humor. So he said, अरे पता नहीं, मैं बचपन में था तब ट्रेन में बैठा हूँ, अभी यहाँ तक पहुंचा. So since I was a child, I'm sitting in this train and now I have reached Baroda. So that kind of slow train it was. And I have heard this joke, him telling number of times, but every time we laugh. That is the way he delivers a joke. So that is one way we can travel in our career, like a Firozpur Janta Express. Whenever it will go, it will go. Whenever it will reach the next station, it will reach the next station, right? And you can, if you are slightly smart, maybe you will take a ticket of a Rajdhani Express. So you sit at Mumbai, you reach in Delhi. Nowadays, in how many? 16 hours, right? In 16 hours, you are there in Delhi. That's a super fast Rajdhani Express. Or if you really know how to hack your journey in your career, you will take a flight ticket. So in 2 hours, you are there in your destination. I didn't tell you one more thing about Mr. Shriram. So as I said, he delivers the joke with a great punch, and he has got great way of presenting the things. And I always look up at him, how one should speak to people. He's much younger than me, 10 years younger than me, but he's a civil engineer working in Mumbai. And because of his presentation skills, he got a job in London. Last 4 years he's working as a civil engineer in London in a prestigious company. And from a mere site engineer, he looks after the commercial operation of that company. And that was a mind blowing journey for any civil engineer. And the last thing I didn't tell you, Shriram, sorry for this, but he is a diploma engineer, not even a degree engineer. So does your mark sheet matter? Does your education matter for success? Does your talent matter in success? What matters is, can you demonstrate your talent? So I want to stop at this point by requesting you all to start demonstrating your knowledge. Start with your lunch table, and you don't know where the life will take you. Once you start, if you don't demonstrate, it can be a Firozpur Janta journey or it can be a Rajdhani Express. But if you start demonstrating, you start using LinkedIn, you start using Facebook, we don't know where you will go. So the three questions is, what is the future of concrete as per you? Not everybody sent me email yesterday. Only I got few. So think about it. What is the future of concrete? What is the future of concrete? Not after 200 years, after 5 years. I gave you some hint about it yesterday. Think about it, write the answers and email to me. How are you going to prepare for this future? Okay, one way I said is demonstrate yourself. Okay, that is the career growth path. The another way is so here is a link for you to download the PDF material. So our course director Anup has posted it on my behalf. Thanks, Anup. How I will prepare for this future? How you will prepare your knowledge for that? We will look at that, the future of concrete, tomorrow. And which are the two areas you will start teaching others? Maybe some concepts from today, our session, some from yesterday, or maybe some things which you already know about civil engineering, which others they don't know so much. So which are the concepts you will start discussing over your lunch table? I will tell you how to make a Facebook post out of that. I will tell you how to do a LinkedIn post out of that, probably a YouTube video out of that, and how to target the HR guys from the top company. How to grow your business in the right direction. Maybe your career or your business. Maybe you're a junior person or a senior person. How to hack that growth. Right, friends? So that's what I wanted to share today with you. And since there are no more questions coming in, we stop at this point, and let's meet again tomorrow, and we will take the next exciting part about the future of concrete and the future of you, the civil engineer. Okay, friends, if there are any questions, you can type it in the comments. I will reply to them. But now I stop our broadcast today, and let's be there tomorrow again at 6 o'clock sharp. So I take your permission and I end the broadcast.